So welcome again, one and all, to our CAD session this evening. This is our first Canada FRC Summer Mentor Sessions 2023. And this evening, we will be discussing Onshape. We did have a chance just before the recording started to receive some feedback in the chat as to where everyone is in terms of CADing and Onshape, and most of our participants this evening are quite new to Onshape. So for that reason, I'm going to give a very introductory session this evening, and please feel most welcome to chime in with some questions as we go. I may cover perhaps the first two topics this evening, sketching and extrusions, just the basic act of making a part. There are some other topics we could do in some future CAD sessions, and I may at the very end just show you some fun I've been having with creating assemblies of imported FRC related parts. And that might summarize our discussion this evening. And there are some links to previous sessions. I will share these in the update, the program update, and a message to everyone. There are two sessions that we did on Introduction to CAD last summer, and there's also an Introduction to CAD 2 that was offered by Team 4152. Just a little preview of our upcoming sessions, a note. Next week is our session on community building. It's on Monday night at 8 p.m. And we're now in the process of finalizing our plans for our Thursday and Friday sessions of August 10th and 11th. And it is worth noting that all of those who signed up for the in-person Studica sessions on the 10th and the 11th, they signed up for all of the sessions. And so with that in mind, we've had to move our Thursday session to Friday evening, and that will be sent out in a program update very soon. We were having trouble getting everything working due to everyone's schedule. And we do have a number of other mentors who are lined up to attend our sessions, at least two, and we're hoping for 3 or 4 more mentors, not only next week, but in our in-person sessions at Studica. So it was my hope to have someone join us this evening to offer an introduction to CAD. That just couldn't work out with everyone's schedule, as we had a lot of volunteers, but not so many who could make it on a Monday night at 8. And so those are just a few notes before we get started. So once again, if you just joined the call, please feel free to text in the chat about where you are with your CAD experience. And I will take a break and look at your I will look at your notes and accordingly tailor what we're talking about. So first of all, how to create an Onshape account. Okay, so, that's great. Thank you. Gilbert has shared the link of how to create an Onshape account. It comes with, for teachers and or FRC participants, Onshape is free. Maybe I'll share the screen here, and I will just go here. Here's our free sign up. Are you a student or educator? If you are other, I'm wondering, well, there may be a way to do that through FRC. I'm not sure. Just have to answer the doorbell. One moment. Sorry about that. Here we are, no one to answer the door. So if you are an educator and or a student, it is free. And you may want to check out your team's voucher codes, because there are voucher codes for our Onshape and or Oh, what's that? SolidWorks, and that usually are shared each year with our FRC teams. So that's one thing that you can do, sign up for an Onshape account. So once you do sign up and you are logged in, you'll be brought to your Onshape user interface. So it turns out that we use Onshape to do our event drawings for FRC. I'll just give you a little tour of a few little things that we've done. For example, there's our drawing of last year's Waterloo University layout. So it is very good for the 2D drawings. If you are working with FRC, you're more likely to want to do 3D drawings. And so maybe I will share from my user interface. I can look at some recently opened files. And here's a 3D sort of model I was working on just before our call this evening. And I was working with a bunch of these parts. It looks like I did a lot. Actually, I imported most of these parts. The chassis, it came as one piece. And then I imported a wheel and centered it on the axle and put a hub on the wheel. Actually, there's the hub there. I'm just playing around with where I can put the hub. I have the hub centered on the axle and I can move it around in my Onshape. So that's where we can get to with our FRC oriented CAD. Now, how am I doing this? This is very good for knowing how to navigate. The mouse buttons are your friend, and having a mouse button with a wheel is really, really useful. So for example, with my right mouse button, I can hold it down to shift my viewpoint around in the screen, just my mouse moving around with the right button held down does this. If I want to zoom in or out, it's my mouse wheel. And if I want to pan back and forth like this, then you will see that that can be done with the mouse wheel held down. That's the default here. You may be able to adjust those settings somewhere in Onshape. So that's very good to know. Within a window, you can pan and rotate your view and zoom in and out, assuming that you have a 3-wheeled mouse, and that will really help. If you don't, there are ways to still move around by using this view tool at the side, and you can do several operations. For example, move in the X direction. I wonder if that allows, oh, there's the X direction view, and the Z direction view. I can click here and maybe see from the top. Actually, here's what I'll do. I will tilt it around using these little arrows and then click on the top, and then I get a top view. Panning, I'm not so sure without the mouse wheel. You might have to look that up. If you do have to look things up, there is an extensive online sort of a set of help features, and you will want to make extensive use of that. For example, I was looking up how to connect 2 parts together, and that's called mating 2 parts. And there are several ways you can do that, and it explains how you may do this in your desktop, iOS or Android systems, and there are the details there. So for example, if I want to know how to pan, let's see what happens here. Does it have a document panel? Maybe I can just look at a view. There we are, views and navigation. So there's some information about views. I think the other article looked a little bit better. And view navigation and viewing parts. Here we are. And now it will give me some instructions how to 3D rotate using the mouse or 3D rotate using the keyboard. Oh, that's great. I've never actually tried that. So let's go back and try it. So it said I can use my keyboard keys. Oh yeah, I can. Look at that. I can rotate around using the keyboard keys. And I wonder about shift. Oh, shift and control holding down. It can allow me to pan, for example. So there's how you figure out how to do things by this Onshape help feature, cad.onshape.com/help. And then you can look up various ideas about what you want to, or various topics related to your CAD experience. Okay, so we're not going to be CADing something like this. We're going to start from the very basics and just how to make a part from scratch, as you will have to do that a lot if you're making a custom module for your robot. Later, when you become more sophisticated, then you can take your custom modules and attach them onto your robot. And that's what we will do this evening. Just start from something very simple. So I'm going to just create, using my user interface here at the top left, pressing the create button, a new document. And I'll just call it a sample part. And create this document. There we go. And here we are at a very introductory view. There are 3 planes, the top, right, and front. I will choose a plane on which to draw my 2D drawing, which I'll create into a 3D part. So I usually choose the top plane. And if I double click it, oh, sorry, that's the wrong app. I'm going to just click it once. Sorry, I switch between apps so much. I'm going to just click sketch here. And it's going to allow me to draw a sketch on that plane. If I click my top view, now I'm looking straight down onto the top plane view. And I can draw a sketch. The concept is here that we maybe will draw a closed geometric figure with some straight and or curved sides. And then we may constrain its side and then turn it from 2D to 3D. So let's pretend or imagine some kind of part, maybe a plate that we might use to attach 2 pieces of our robot. So I'm going to just make an arbitrary shape here. I just clicked on the end point of one of my parts here, and I can continue drawing lines just like this. And then maybe draw one over here. At a certain point, when I'm done, I'll hit escape. And that was my line drawing feature. Whoops. Okay, so I've just drawn my several lines here for a 2D part. I can also draw some curved pieces in the lines. Like, for example, there's a 3-point arc. So maybe I can center it here and make it touch right there. Now you see I have a closed loop, but there's an extra section there. I don't need that section. So I can actually cut that out with a trim operation. I just clicked the trim tool and I click on that, and you see it highlights it, what it's going to trim. It goes between 2 points on my 3-point arc. There we are. Now I have a 2D shape, and I drew it really quickly. However, maybe I have in mind some particular dimensions and maybe some particular angles for our different parts there. And our toolbar at the top here will help us. It generally goes from left to right. Over here, I do my drawing, and then as I move here, I adjust my drawing, and then I constrain my drawing. So I just used the line drawing tool and an arc drawing tool, and then I trimmed off one piece. I could do all kinds of other things there. And now I'm going to constrain it. So what will I do? Well, there are a few things that I really should know just to make sure. Well, since it's colored in gray, it is a closed part. If it's not colored in gray, it may be that 2 or more of your lines did not join. So here we have one. Oops, I just accidentally trimmed that. That's no problem. I'm going to Control Z and put that back. So what I want to do, maybe, first of all, that looks like maybe I wanted it to be a right angle. So I'll make this one vertical and that one horizontal. So here's the horizontal tool. I clicked it, it's activated, and now when I click on this line, it will become horizontal. And horizontal tool is still there. Here's another horizontal constraint. So for example, let me try that again. Oh yeah, there. The horizontal constraint is showing there. All right, so now what about a vertical constraint? There's a vertical constraint and I want this line to be vertical. There it is. There's a vertical line and there's a horizontal line. The constraints are showing up. And so then I know that they have been constrained. And what about the length of these lines? Well, here's my dimension tool. Let's see how long this line is. It looks to be 67 millimeters. What if I wanted it to be 70? I'll just correct that. And I can do similarly with the others, the dimension tool. I'm just making this completely arbitrary. Of course, you'll have an idea of how you want to dimension your figures as you go. So something that's very much worth knowing, if you add too many constraints, you could get an issue. And I'll show you that in a moment. I'm going to clean this up. I'm going to make this circle tangent to this line using my tangent tool. So the tangent tool is on and I click one entity and then the other entity and they should be tangent. Now they're tangent, there's a nice round kind of shape. Okay, so since they're tangent, and maybe I can also put the dimension on this circle, it should give me my radius. So there's my radius. I've constrained the radius. Let's say that it's 80 millimeters. Now I have to be careful. I've constrained all of the line's lengths except for this one. If I try to measure its dimension, I'm going to get a particular dimension, and I have constrained it such that if I change it, there's going to be possibly a problem. It may end up changing the characteristics of my drawing. It actually was allowed to change it because I still have not constrained this part here. And so it actually just changed that angle. Maybe if I try to fix this angle or do something else, like for example, if I tried to make this 1,000 now, it might break it. And there, it broke it because with all the other constraints I put in there, it can't have that radius of circle and those lengths of lines with the horizontal and vertical, and then have that as 1,000. That's a contradiction. And so it gave me an error. Put it back to 100 and it's fine. So you need to apply geometric knowledge when you do your constraints and make sure that everything is in order. And there is a lot more that I can do. I can make certain lines perpendicular. I can make them equal. I can make them parallel. I can make two circles concentric, all kinds of things that can be done. I've just shown you a sort of an introductory sort of way to do a sketch. And since this sketch is constrained and there are no red indicators that I've got a contradiction, I can pretend that this is the piece that I want. I'm going to accept it. I clicked that check mark, and now I have my 2D sketch of my object. What if I want it to be 3D? It's going to be a piece of metal after all. And so that's what I'm going to do. I'm going to select my sketch over here in this feature tree and do an extrusion. Once again, once I've come out of my sketches, I have a bunch of things that can be done in 3 dimensions. And the first one is to extrude. So let's say that I have a 2.5 millimeter thick piece of metal. And there we are. There's my 2.5 millimeter thick piece of metal. And now I have a solid piece of something. So there's the first step in my engineering process. I've imagined a 3D piece of metal, but maybe I will need some holes or other features to be drawn in it. And that's no worries. I could have drawn those holes before I made it 3D, Or I can select a plane, like for example, the top plane. Note that I just selected the top plane by clicking with the left button. And I can draw a new sketch on there. I'm going to draw a new sketch. Here's a sketch 2, and I will start drawing. Before I go too far there, I think maybe it's a good place to stop, though. Let me just check our chat and see if there are any questions or if there are any suggestions. None yet. Please feel free to pipe up if you have a question or a suggestion. So I will continue along, and just if you have a question, please remember to ask. All right, I've selected one plane of my 3D piece of metal, and I'll draw a sketch on it. And there is the sketch has been started. And if I go down to my top view, you see sketch 2 is now on this plane. And let's imagine that several holes are going to be drawn in here. And that's what I'll do. I'm going to imagine maybe a 5mm hole. And oh, that was pretty close. I'll take my dimension and make sure it's 5mm. Okay, so there's a 5mm hole. However, I can imagine I want a whole set of holes because they're going to be some rivets. All right, no problem. I'm going to make a linear pattern of these holes. So with this particular linear pattern tool, I've selected the feature, this hole, well, right now it's a circle, and it's going to repeat 3 times in this direction at a distance of 25mm. You see there are the 3 holes. Let's change that to say 10mm between them, and we'll make 10 holes in a row. There we go. Great, there are 10 holes in a row, and they're moving along a linear pattern. I can also make them go along in another direction if I like. So I'm just going to keep this right here at just one linear pattern of holes. And let's say that that's finished. And there are 10 holes that are going to be cut now. Now I have to cut the holes. I've drawn where I want the holes to be cut. How am I going to cut them? And I can move through my tools here. And there's a hole that can be cut. And let's try that one. Oops, I have to select this sketch 2 first, and then make the hole. Oops, it only did 2 of them. Let's try that again. Oh, I just had to click on them and select them all with my left button, and then it made all the holes. So there are 10 precisely created holes. If you have access to a CNC machine, this part could be exported and laser cut out of a piece of metal, for example. And there we are with some, well, 2 steps now, a basic sketch, and then also a set of patterns etched in this sketch, some holes that are in a linear pattern. A very nice feature of these CAD programs. If I want to change something now, that's actually okay. For example, I can go back to my first sketch. And so long as I don't break things, I may be able to, for example, take this constraint off. I'm clicking on it and I should be able to hit delete. And now I'm going to change this to 80. A slightly different shape, and that's great. And now that change propagates through my new sketch. What if I want my holes to be bigger? I can go to sketch number 2 and maybe make them 6mm holes. And there we are, 6mm holes done. And when I accept it, now I have a bunch of 6mm holes and I changed one of the dimensions. So you can go through your feature tree, find parts that you've already done and double click them and then make modifications as you see fit. And then you should see the changes propagating in your model. All the time, you just have to consider physical reality of what you're doing. If the requested changes are not in keeping with basic geometry, you will get an issue. So on this plane, for example, I can click again and make any number of sketches, and I can do some other modifications. Let's say that we've done all the modifications we want to do here, but there are some maybe aesthetic sort of changes we want to make. What if these holes, we want to come out a little bit more rounded, or maybe the edges or something like this? Well, there are some features here in our CAD program that allow us to do that. So looking here, we have fillets and chamfers and drafts and different operations that we can do on a 3D model. So I'm going to click an edge and show an example of one of these. So there's my edge over here. What if I want this to be kind of rounded off? I click the edge and only that edge line is selected. As you see, it's highlighted in orange. My left button clicked that, and I can go over to one of the features here and round it off with a fillet. And right now it's a 2mm fillet. Let's just make it 1mm because it's not all that thick. There we go. A 1mm fillet just went into our 3D object. And we could do that with several other edges if we want. There's another edge selected. Go over to our fillet tool and make another 1mm fillet. It already selected that. So now we've rounded our piece of metal on one edge to well, just round it off that edge, for example. You can do that with also holes. I'm wondering if this propagates through. I haven't actually tried this with a linear pattern. Let's try and see what happens. Sometimes you end up breaking things if they're not meant to be done in that order. So I've selected one hole. Let's see if it allows me to chamfer that hole. Yeah, it did. Okay, I did a 1mm chamfer, which is just a straight edge instead of a rounded edge. And there, one hole has been treated that way. So I could actually select several others and do the same. You probably want to do this with a linear pattern in a different way. But anyway, I'm holding down my shift button and I'm selecting the rest of the holes. And having selected those, I can do the same thing, fillet them or chamfer them. And there we are. All of them have been chamfered now. So those are some basic operations, and that's the basic workflow of making a single sort of simple part where you draw a sketch, as you can see here. We extrude that sketch to 3D, maybe make another sketch on one of the sides and add some features such as holes, fillets, and chamfers. And we end up with a part that could be manufactured with a sort of a shop tool. Sorry about that. Finally, the problem at the door is resolved. Okay. So there we are, and that's how to do a part that you may manufacture then as a piece of your robot. Okay, so it may be worth it, since this is an introductory call, to repeat this process. And if you're following along with some Onshape or with Onshape on your computer, you can try to follow along. If not, I think repeating it cannot hurt, because there are many steps that we went through. And I'm going to repeat and make a similar part and maybe show one or two other features as we go. So let's go back here to my Onshape sort of home. This little button on the top shows me all the different files that I've worked on. There's a sample part. I'm going to create another one, another document, and I will call this document sample part 2. All right, so we find ourselves at the very beginning screen, and there are 3 planes from which to choose. Out of habit, I tend to choose the top plane, and on there, I'm going to create a sketch, remembering the idea that we move from left to right. Take a note here. When the sketch is finished, I have to click this little green check mark to be out of the sketch. When I'm in the sketch, I get the menu that is associated with the sketch. And when I click OK on the sketch, then I get the menu associated with 3D part manipulation and modification. So my sketch is empty. I can go back in there by just double clicking on it. And then you see that I'm in the sketch as there's this little check mark waiting to be checked when I'm done my sketch. So using my view, I can go to the top, and when zooming out with my mouse wheel, you see sketch 1 there. This time I'm going to make some kind of a circular part. So I will start here by clicking on this circle tool, go right to this center and draw a circle very quickly here. You'll notice I started here. It's a nice place to be centered, and that can help you with some other geometric considerations later. And last time I just sort of made a closed shape and then extruded it and then added features. Here, I can actually add the features before extrusion. So in here, I'm going to put a few patterns that are going to be repeated around this circle. And that's another reason to start with this dot, this center point here, this origin, as it's a good reference point for rotating features around a circular pattern. So first of all, maybe a smaller circle in here, maybe drawn. I'll just put it somewhere inside and put some kind of dimension on it. And when I'm done, maybe I can put a inscribed polygon here. That one there. Oh yeah, once I click it, then I move my mouse around and I can decide how many sides it's going to have. How about 5 sides? There we are. And I can also have some kind of arbitrary shape, maybe with a few lines drawn. Okay, there are 3 features that we may rotate about our circle to get some regular features there. All right, so let's select a few of them. I escaped to get out of my drawing tool and tried that again. I'm holding down Shift to select multiple pieces at once. Oops, that's too many. Okay, so I've selected the first 2, just the center point there and this triangle. I'm going to try doing a circular pattern. There we are. Oh, it only selected the first one. Okay, I'll focus on the first one to begin. And you see here, there's a repetition of 3 times. Let's make that 6. There, it's repeating 6 times around the circle. And there we go. Okay, so I just saved a lot of work and repeated that triangle 6 times around the center. Now to do that with my hexagon, or sorry, pentagon, I'm going to select all of the sides. And I was holding down my shift again as I was doing that and using my left button. Let's try to do a circular pattern with this one now. There we are. It starts with 3. Can pan up and look at it where it says 3 times there. Let's make that 10 times. There are now 10 hexagons around the center. And maybe I could make it 12 to make it a kind of a multiple of the 6 that I already did. There we are. And there are 12 pentagons distributed about the center. And finally, let's go to this circle, select the circle and make a circular pattern. And very nicely, since I chose this center, it makes it very convenient. It already knows where I want my center. I'm going to maybe repeat this 18 times around the center. There we are. And there are a bunch of shapes inscribed on my circle. Maybe one final one here. Put another polygon in the center of some sort. There, a hexagonal part in the center. Okay, so there's another way to work. In a circular fashion, you can use circular patterns to repeat your geometric figures. I can also put dimensions and constraints on all of these if I like, and then be able to work with them later. So I didn't really focus on the constraints, but that can be done. Just as a reminder, for example, dimension constraint here, I can dimension this circle, and right now it's 95 millimeters. Let's make it 90. Okay, on the whole thing just dimensioned. So it's all been linked together. So if I want to particularly dimension these, I would probably set their dimensions before doing these patterns. So I wonder what will happen now if I try to change the dimension of this circle. Let's find out. I'm going to click just on this circle here. And it says 6.6 millimeters. How about 5 millimeters? And all of them changed, because you see, I changed the first one on which I based my linear pattern. If I go to change one of these over here now and make this 7, what happens to the others? Oh, only that one changes and it gets angry at me. So I'm just going to undo that with a Control-Z. So I could go and maybe look at this dimension. And that's 19 millimeters. What about making that 17 millimeters? There, now all of my triangles change. Okay, so let's say that I'm satisfied with this kind of wheel pattern. I'm finished my sketch, and now I want to make a 3D extrusion out of it. Selected this whole sketch, and moving from left to right, we started with the sketch. The next thing you usually do is extrude. And now we've got a nice pattern that is done in 3 dimensions, and the holes are already there. And there we go with a 3D pattern that has been extruded with the only one sketch rather than 2 this time. Once again, as we were doing some modifications, I'm going to look at the fillet and the chamfer, or the chamfer. So I'm going to select a circle edge and fillet it. Can change that maybe to a few more millimeters this time. How about 5? There we are. And what about the other side? Oh, I just did that. I didn't mean to do 2 of those, but that's fine. There we are. So there's some kind of 3D shape that could be a plaction wheel that you manufacture, or some other component for your robot. All right, so there are a few introductory comments about making parts in Onshape. So I'll just take a break for one moment here and see where everyone is at in terms of any questions or inquiries. Here we go. So Gilbert has a question about editing the pattern after it's created, like changing from one row to 2 rows of whole. So let's go back and see how that one works. And then Ram has a question about SolidWorks versus Onshape. And one thing that's very nice about Onshape is that, first of all, it only requires a web browser, and you can use it on a wide variety of laptops and computers as long as they have browsers. And that's quite different from SolidWorks. Traditional SolidWorks has required quite a hardware setup on a computer, and usually a Windows computer. I'm not sure lately, as I'm not up on it, but maybe SolidWorks is moving towards a web-based solution, but I'm not definitively sure about that. But for sure, Onshape is web-based and it can be run in a wide variety of browsers. So it's quite accessible that way. And a very beautiful part of the Onshape is that, let's just go sharing the screen here again. I can share this with whoever I would like, and then other users can modify and see what I'm doing right away. So this is share, not unlike a Google document or a Microsoft document that you may share with other users. And then you can have a whole team working on an assembly of parts in real time. Whereas before, in SolidWorks, when it's only on one laptop, it's really hard to share and requires quite a setup of file sharing and checking and version control. And speaking of version control, there is a built-in version control feature that's not unlike GitLab or GitHub. And here are the versions of this file. So for example, if one of my manufacturing sort of team wants to work on this file, but I'm working on it, we can make a new version of the file. And then our changes are not going to be incompatible. So that's something you may look into. I think it's beyond the scope of this evening, but very much worth knowing that you can have a whole team working and use versions to keep track of different users modifying the parts, and have multiple team members working on the same robot. So I think that's a really sort of good feature to look at. I'm going to go back to our previous file, going back up to the top left here, and we will go back to the sample part. And Gilbert's question was, can we modify this number of holes here? Well, let's go back to our second sketch. That's where we drew the holes, and look at it from the top. So with this feature here, there should be, I am not sure why, it's only showing in one direction right now, as I have definitely done it with 2 directions. Let's go to our feature here for patterns, linear pattern. There should be another feature here that allows me to determine how many in this direction. So what I'm going to do is try from the beginning again, maybe with some rectangular pieces. So here's a rectangle drawn, and I will, escape from that and use Shift and hold down all 4 sides. Let's see if we can apply another linear pattern here. There we go. So there is a 1 times feature here, and I think it was probably out of view on the other one that I was going. So we can go back and fix these circles in a moment. And it's going upwards and to the right. So I want it to go downwards. So first of all, I'm going to make maybe 3 layers going up. And you see they're going to be separated by 25 millimeters, but they're in an upwards way. So why not just make it negative 25 millimeters? Now they're heading down. And over here, I'm going to have it repeat 5 times. There we are. And in this direction, let's make it go 20 millimeters. Okay, so there's a linear pattern in 2 dimensions. So based on what I just noticed there, let's go back to this one. And this linear pattern, I believe if we select the linear pattern, we may be able to, maybe what I'll do, I'll just erase these ones and try again. Okay, so start with my circle and try a linear pattern again. Ah, there we are. The reason I couldn't repeat it in that direction, it was off the screen. So I want this one also to go 3 times, and maybe this one to go 7 times. Double click it there. 3, it's good to hit enter to make sure it's repeated. Now it's going in the wrong direction. That's okay. I can make this a negative, maybe negative 10. There we are. And maybe this one will be 10. Okay, that's also an arbitrary pattern there. So just zooming out allowed me to make that modification. So you see, I've made quite a change to the nature of our part when I click yes on my sketch. Let's see what happens, because there were some other features there that had been done. There could be a problem because our chamfer is gone now and our hole is gone. So I might have to go back to sketch 2 and make another hole. There we are. Whoa. Oh, that's interesting. That's not what I intended. Oh, because it's making holes on the vertices of my pattern. And for some reason, I'm a little rusty on this one. I don't know why it's making me highlight all of these. I'm sure there's a better way to do this. But as there's only a few holes, there we are. So definitely not what I was expecting with these holes here, but that's our hole feature. I believe there's another one that I'm missing, and I'm not sure why. Circular Boolean. Oh, maybe it's just extrude. So what I'm going to do here, instead of a hole, let's like highlight sketch 2 and do a negative extrusion. There we are, remove. And we remove 25 millimeters, so that's going to go right through. And hopefully that's okay. There we are. I had forgotten that. Different CAD programs have these different shortcut keys. So we're extruding again, but negative extrusion. And you can see there are several other ways to do this extrusion. So there's my pattern, and I can modify it as I like. So to answer Gilbert's question, yes, there is a way to modify it. If I go back to my sketch 2, I can change this 3 to a 4. As long as I hit enter, then I have 4 holes. And this 3 can also go to a 4, made a modification. And then when I click this check mark, there's my modified part. There we go. I see there's a chat. Is there a beginner project available that can be given to students? There are a number of really great tutorials online. And it's really hard to answer that question because students come with all different levels of interest and capability and availability to work on the CAD. And so there are many answers to that question. And I can picture many students that I would have given different projects to start them off. So, for example, some students may want to jump right in and start working with an FRC robot. They want to see the big picture right away. Others, they want to learn step by step and learn how to make a part and then assemble those parts. So there is no easy answer to that. I will see if when we post up the video and we include the files, we'll have a link to a few tutorials. But what I usually do to solve a problem like that, let's just go here and do a little search. Let's say Onshape introductory. This is what I've done for most of my career, and they're usually some pretty good videos. So many of the things that I discussed this evening, creating a new project, adding features, using the view, selecting a sketch plane, they're all in this one that just comes right up here. Creating your first item in Onshape, there's a beginner tutorial. There are some nice ones, for example, Onshape, oops, I don't know why it's on caps, Onshape assemblies. That's the next step, taking two or more parts and pairing them together. So lots of great tutorials there. Here's one that I was viewing, build your first assembly. And this gives a lot of the ideas that you would need to start building FRC robots, as there are multiple pieces that have gears and levers and the like, and they're paired together systematically. So this is a really great tutorial. Once you know how to make a basic piece and add features, then you want to know how to put them together in an assembly. This is a great way to do that with this tutorial here. Build your first assembly. And look here, the Resource Center on Onshape has a lot of videos, and you may want to go there. Lots of different choices about Onshape learning in the video section. So hopefully that will get you started. I'm sure there are many, many more questions. What I might do is just give a very brief tour of a few other things that you might do in Onshape. Going back to my Onshape here. Okay, once I'm logged in, I go to the top right-hand corner and click, and there I am. I find where my Onshape is again. You'll notice here that I have different projects in different directories. I made a few of these parts here. I may organize them later in a different directory. And there are several other projects that we made in other times. The Everybot from last year, I imported into Onshape. That was the 2022 Everybot. And yeah, you can create folders and the like and drag and drop your items into these folders. I'm not going to do that now, but I could just drag this sample part and put it anywhere I like. So that's what I did with my event drawings, for example. So let's just go back to my home screen here, and maybe this sample part. What if I need to make a drawing of this part? This might be for an engineering purposes or sending to someone who's going to fabricate the part. So what I can do is select my whole part here, part one, and right click it, and I may create a drawing out of the part. And I can have no views and add them, but here's a nice way with 4 views. It's a default, sort of a standard drafting or engineering approach to a part. And there's my part from the side, not so exciting. And from the top, there are more features there, and there's an isometric view. Each of these can be resized and worked with, and then I can label it. Once I'm in this sort of dialogue here, I can also put dimensions on for the purposes of manufacturing. So just highlighting a feature and putting on the dimensions so that whoever's CADing can figure out what's going on. I can also put angles and different labels and whatever I need, so that I have enough information for the part to be manufactured. So here's one important thing. I need to know how far it is from here to there. What's the spacing of those? Oh, there it is. I just clicked on the 2 dots. And how about from here to here? There's another one that's 20, 25 and 20. And what about the side length? Here's the side length, 6.06 and 8.48. Interestingly, I didn't really specify those anyway, and you can move these around and these dimensions, adjust them. Maybe it actually is supposed to be 8.5, so you can double click and override it. But this one was measured from my CAD sketch, and so hopefully it's okay. And then I can move them around and just make them sort of agree with each other as to where they are on the page so they're not overlapping. So dragging and dropping the various dimensions may help you to create your drawing. And down here, can maybe put a title and put the date and whatever else I need to indicate what's going on my drawing. You also see there the scale is not so great. I might be able to scale these up. And if I look at the properties, the scale here is multiple values, but let's go to one of these. Let's just click on one, right click and view the properties. Right now it's 1:4 scale. What if I put it as a 1:3 scale? Oh, that makes it bigger. It's taking up more of the page. And that's what I can do with my other parts. Right click, go to properties, and maybe make a 1:3 scale, taking up more than a page. Remember this check mark. I forgot to do that with the other one. And there we are. Hopefully it stays at a 1:3 scale. Oh, I've run into there it is. So properties 1:3. And as long as I hit the check mark, then it's okay. So I've taken up more room. Maybe I don't need these views because they're not actually offering all that much. So I could actually just highlight them and delete them and then make these ones bigger as I wish. And then you can also put text here, like a nice title. And maybe it needs to be bigger text. It's a really great interface. It's quite intuitive. It doesn't take all that long to learn, and you could put a title there, center it, drag it around, do all kinds of things with it, and come up with a drawing for someone else to be able to use. Now, looking here at our interface, in doing that, I still have my, Zoom call. There's my Part Studio, and there's where I did my 3D drawing. And in the same file, they're just in different tabs. I have an assembly here, it's empty. I could actually import several other pieces and begin making an assembly. So for example, one thing that I did, and this is maybe going to finish off the sort of the topics for our call, there is a very beautiful and free library of parts called CAD. And just have to drag this Zoom call information out of the way here so we can take a look at it. So what I did today, I just wanted to know, well, how can I import pre-made FRC parts? So FRC Onshape import parts library. I just did a search, Onshape import FRC parts library. And there are several items that come up, but CAD came up fairly early in the search options. And it's in the App Store for Onshape. And all I did was subscribed. There was a subscribe button, and now I have my free use of this feature. And there are some product support notes here at the bottom, and you may see about how to begin using it. So once it's activated, I think I had to restart my CAD 1 or 2 times. I'll show you what I was doing just before our call this evening. Here's a imported chassis, and I imported this wheel. What if I want to import another part into this assembly? Well, here's a very beautiful feature. This button comes here, the CAD inserter, and it's going to allow me to go through a whole catalog of FRC related parts. Let's go down to something like a hub. Okay. And 1/2-inch hex bore aluminum Versa hub. Used those all the time when I was an FRC mentor. I just clicked on it. It should have probably appeared in the document. There it is. And so, wait a moment, that's not in the right spot. I want to center it about something. What if I want to center it on this hex shaft here. So one way to do that, I can first of all create a center for this circle and this circle, as it's also centered on the shaft. And then I might be able to create a connection between this plane and another plane in the hex shaft. There are 6 little planes here, and if I can make this plane, for example, the same as the plane on the hex shaft, then I will be able to put that part in place. So this is the general process that you go through to work with parts and assemblies. I'll just show this very briefly, and this would be a whole other topic for another time, but why not just show it here just to give an introduction. So I'm going to create a circular mate, cylindrical mate that is. And now I need to click on 2 circular objects. The first being the circle defining the outside of this shaft, or sorry, of this hub. And then another one, this bearing here also has a circle that's centered about the shaft. So if I click both of them, now the hub must be centered on the shaft. And you see it gets right down onto the shaft. An interesting thing, though, if I pan around, it's kind of inside the robot at the moment. It's inside the rail. So since it's constrained to be concentric with the shaft now, I can move it along. And I can put it anywhere I want on here. Not that you would. I'm probably certain you put some hubs and wheels like these on here. But there's the first step in creating a connection between these two. Now, if I look more closely, it's likely, and you can see here, they're not sharing the same orientation. So I actually have to somehow make a planar mate as well. So I'll connect this plane and maybe another plane inside this hub here. Let's see if I can get it from this side. So did that work? Let's find out. Not quite, because now they're sharing the same plane, but in the wrong orientation. So I might have to actually do it with another one as well. So let's try that again. Maybe I'm going to take that planar mate out of there. And try again. How about a planar mate from this surface to this surface? There we go. And that worked better. I had a better view at the plane. And now those 2 planes must be the same plane. And so now not only is this shaft centered with the hub, one plane of this hex hole is centered or coplanar with one plane of the hex shaft. So those 2 constraints together make sure that this is aligned on the shaft. And now if I select everything, I should be able to move this up and down. Oops, maybe I've constrained it too much. Well, certainly, I think I overdid it there. This one that I was just working on, it still can move back and forth on the shaft. Or at least it could before our call this evening. And that's probably a good place to stop based on this not working. Oh, there we are. I can move this wheel on the shaft, for example. I've only constrained it to be concentric with the shaft. And that's what I was trying to do. Just move this back and forth. So I'm sure there are many more questions. If you have specific CAD needs, please feel most welcome to reach out. I'm sure there will be lots of opportunity for future calls. And I really like this comment from Ram, scared to start teaching my students Onshape when I don't know it well myself. This is something that really an approach that I took in many of my classes, because we were doing FRC and there are so many things to learn, I actually didn't teach Onshape. What I did is I divided my class into numerous teams, only some of whom learned the CAD while others were learning, say, the coding or the sensors or things like this, and had them learn it and then teach me and everyone else. So I wouldn't get in front of the class and just do one session on coding. What I did, I would get in front of the class and say, depending on if it was the computer class or the FRC club, if it was the FRC club and it was time to CAD, maybe 2 or 3 students would be CADing, while some others would be doing manufacturing. And then that way, I think it makes it much better if you put the responsibility for the learning on the students. It will call them to a higher level of operation and rapidly multiply the amount of learning happening in the class, because if it all has to come through the teacher, then there's a kind of a bottleneck for the learning. So maybe that might help you, and never be afraid to say, oh, I don't know, or I forgot, or let's learn that together. So when I did CAD, for example, I might have done a very short version of what we saw here and just said, students, okay, go ahead now, try the CAD and show me what you come up with. And my students came up with incredible things, not having done CAD before. So hopefully that might help in that regard. Dear friends, very nice to see each of you this evening. If you have questions, please feel most welcome to reach out, and we can, of course, organize some more CAD sessions. We have a representative of Team Dave this time next week doing community building session for us. And hopefully several other mentors will be attending our studio sessions or Studica sessions in August 10th and 11th. So with that, thank you so much again, everyone, and looking forward to seeing everyone very soon.